So today is Thursday, the 13th of April, 2023, and welcome to today's Tech Hour. And its subjects are Unlatex and a Fermi estimate for reprocessing the archive. Let me say, first of all, that I'm really looking forward to the archive's first accessibility forum, which is taking place next Monday. And it has been a tremendous stimulus to me to know that they have 2,000 people registered for it. I once went to an exhibition on, amongst other things, magic, and there was a very nice video demonstration from a magician polishing his glasses. And he talked about what magic is, and he said that magic is only magic when there's an audience. If there's no audience, it's not magic because there's nobody to be deceived. And he then poked his finger through the lens of the glasses. He appeared to be polishing the glasses, but there were no lens in the glasses, and he deceived us. So that way he was teaching us what magic was. Well, it's really important to have an audience. Software is not software without users of some form or another. And I'm very pleased that Jason White, who is, I think, one of the panelists on Monday, is here because he's, I don't know if blind or visually disabled is the preferred term, but he is part of the audience.
Unfortunately, not a panelist this time, just to clarify the record.
Say that again, please, Jason.
Unfortunately, not a panelist at this one, just to clarify the record. Thank you.
Oh,
sorry.
Okay.
Wish I were.
Okay. I'm sorry to have gotten that wrong. So to follow on from last year, for the past 500 years, print has been a tremendous success in providing access to what would otherwise be handwritten manuscripts or handwritten copies, because that's what print originated as. And until the invention of the typewriter, all the stuff that went to the printer was handwritten. And the typewriter arose, roughly speaking, out of print. And only in the 1950s did we start to get significant numbers of electronic documents, I think, unless you count the IBM punch cards, the holograph cards. And print is so valuable because it provides a way of disseminating information, but it's obsolete. And we're having to rethink, perhaps in a hurry, what we do with print. So print did solve the problem of accessibility in the pre-digital age. Now, there are 5 questions I'm going to be answering: who, why, what, when, and how. So who is the visually impaired? The why is because many people are, and it's a social loss and an economic loss and a human loss that these people cannot partake in our shared culture as easily as they ought to be able to. The question is what? I'm focusing on the legacy preprints on the archive servers. And I choose the legacy ones for 2 reasons, at least 2 reasons. The first is that the problem is well defined because you can't change the inputs, they're legacy. So you've got a well-defined input statement. The second thing is we have to know what the present difficulties are before we can change our software to get new difficulty, new systems. And the third thing is there's an awful lot of them and there doesn't seem to be much focus on it. The when, well, I'm hoping we get something that half decent in 12 months, which means that we can't build anything large. That sort of restricts what we can do because we're trying to produce something that that delivers within 12 months. It may not be brilliant, but we want to be able to deliver. And then the how is a simple-minded, visually impaired focus on a visually impaired person attempting to read a PDF? Well, the problem with the PDF is that it's inherently a visual format, and it's a typographic format that's using visual styles and so forth, and it breaks things into pages and it breaks lines and it's got hyphenation, and none of these things are any trouble to the sighted people, but they don't work at all well for the people who are not sighted. So there's an information content that they like to have presented, and the great thing about starting with the PDF is that at least a large number of people have looked at it and said that it's correct. So it has some chance of really having the information that we've got in it. Now, the problem with the PDF is that the input has been turned into a sausage. You know, we've taken something that might be better formatted and processed it for a particular output. So we're going to un-PDF it, because the documents on the archives have been created using LaTeX, and LaTeX ships out a box to create a PDF. There's essentially nothing in the PDF that hasn't already been specified in the box, or there's very little that hasn't already been specified in the box. One exception for this is the graphics. In the box, the names of the file that contain the graphics are included, but the graphics aren't included. So graphics have to be dealt with separately, but you do want to deal with graphics separately anyway. So the starting point is the box that LaTeX ships out, and I'm hoping that Jason will try and keep me honest if I regarding how I see things. So I've sent Jason a file called LaTeX example. Are you able to look at that?
Yes, I think that was the one that has all of the low-level typesetting macros in it. Is that right?
That's right. Well, then they're not even macros. The macros you can have. You can define new macros if you want to.
So are they the primitive?
They're primitive commands,
yes.
And they're typesetting primitive commands. So it's a very restricted, very controlled vocabulary. About the only variation you have in the vocabulary is that you can introduce new fonts. And for a sighted person, this file is hard to read, and their preferred way of reading it is turning it into a PDF, and then it's very nice and exciting and interesting to read. But for somebody who's not sighted, that's not an opportunity, and we're trying to avoid turning it into a PDF and then using a PDF screen reader. We'd rather cut out the PDF as the middle person. So the objective I've got is to create the beginnings of a screen reader, but not for PDF files, but for the things that LaTeX produces just before they become PDF. And the second file I sent you, Jason, is, I think, some source code in Python.
That's correct, yes.
I tell you what, I should start screen sharing at this point.
While you're doing that, I'll just comment that yes, that those primitive typesetting operations are also difficult to read with a braille display, because you're essentially reading one line at a time. So it's not
That's right.
All that useful directly.
Yeah, yes. I did notice something, which is the dots in the printout in the visual display. There are dots in the visual display, and they allow you to move along the line horizontally. And that in typesetting term, these sequences of dots are called leaders because they lead the eye. And they also allow you to sort of move your lines up and down vertically, like the lines in a graph paper. So the dots perform a function, but if you're unsighted, then you may just want to know what's the relative indent to the previous line, or what's the absolute value of the indent. It's a sort of different way of providing information. Now, the second thing I've got is a source file that will process this box file, and I've got it up on I'm sharing it on my screen. The important thing about it is that it's less than 200 lines long. So I'm not doing a lot of work. And if I run that program, you won't be able to join in on this, I'm afraid, Jason.
That's all fine.
Sorry?
That's fine with me.
Okay, so I'll describe what's happening. So I've run Python interactively at the command line. I've run Python with the script, which is the script I just showed you and sent you. And the script creates a box. And the box is a rough translation of the first 25 or so lines of the file I sent you. And the people who are sighted can see that there's lots of hbox and vbox and glue commands, and also some font names, OTR1, CMR, MN 17.28, followed by the letter N, and the same sequence followed by the letter A, and so forth. Now, what we've got, in fact, is something that we can interact with programmatically and at the command line. So the box has got a 0th element, which is an hbox that contains a special. And it's got a first element, a 1th element, which is a piece of glue. And I type box 0 and box 1 to see that. And if I type box 2, I get a whole bunch of stuff. So if I type box 2, 0, I get a VBox that contains glue and an hbox and an H containing an hbox, which isn't very interesting. If we type box 2, 1, so what we're doing here is we're imagining we've got a document object model and we're just going through the nodes one at a time. The second child, the first child of the second child, and so forth. So box 2, 2 is also another piece of glue. This is very boring. Box 2, 3 is more interesting because it's got the text in it, and box 2, 4 doesn't exist. So box 2, 3, 0. So what I'm doing is I'm navigating my way through this tree by using a sequence of offsets. So box 2, 3, 0 is a write command. Box 2, 3, 1 is a glue command. Box 2, 3, 2 is another hbox command. Box 2, 3, 3 is more glue. Box 2, 3, 4 is more glue. Box 2, 3, 5 is a penalty. Box 2, 3, 6 is more glue. Box 2, 3, 7 is more glue. Box 2, 3, 8 is more glue. Box 2, 3, 9 is still more glue. What's happening here? box 3 through 10, is an H box. So we've got a vertical box, which a whole bunch of things in, including bunches of lots of glue. And then we get an H box, which is box 2, 3, 10. And then if we put 0, we get the first element in the H box, which is glue. And the next element in the H box is an H box that contains glue and an H box. And that's not very interesting. Then we get a penalty. And then we get a character. We get the character A in a particular font that's at 17.28 points, so it's probably a heading. Character 4, 2, 3, 10, 4, is the letter N, lowercase. 2, 3, 5 is more glue. 2, 3, 6 is E. 2, 3, 7 is X. 2, 3, 8 is A. 2, 3, 9 is M. 2, 3, 10 is example. So what we're doing here, Jason, is that we're reading the box file, which is in some sense the PDF, instruction by instruction. And once we understand what's going on, we can say, oh, well, we can skip the glue most of the time. And we'll put it back in if we need it, for example. So the last half dozen things were AN, then some glue, and then EXA. Now I happen to know that that glue's got a significant width and it's an interword space. So the basic picture I'm trying to communicate here is that by taking that text file and turning it into a Python object, we can access the object by giving a path to each element in the object. And the path is a sequence of whole numbers. So 2, 3, 10, 6 means start with the box, take the item at number 2, and in there take the item at index 3, and then the item index 6, and the item at index 7. And it's clear that you can programmatically go through the whole tree. You can walk the tree in that way, picking out the things of interest. And in a certain sense, when we read the document visually, that's what we do. We find out that there's a horizontal box that contains some letters in it, and we read the letters. So always letters, the text, will always be in a horizontal box. It can never be directly in a vertical box. And the horizontal box is usually a line in a paragraph. So up to a point, we can read this file as a sequence of characters. And it's not that difficult to program so that it can be read as a sequence of characters. And because the focus is on accessibility and getting something done in 12 months, the groundwork for the whole of this is to take an article in the archive, to produce the box files from it, and then to load the box files in as Python objects. And that provides an alternative platform for what we might call a screen reader or a PDF reader or a box reader. And at that point, it becomes a matter of Python programming, and it doesn't require, a lot can be done without knowing anything about tech, because it only uses these particular commands. There's a restricted vocabulary of commands, so you only have to know a small number of commands. And you have to know how the commands work together. And in some sense, from the information given to you, you have to piece everything together. And it's not that difficult because sighted people have no difficulty reading that information once it's been presented as a PDF. So The only thing you're particularly missing is the positional information, and the glue gives you the relative positional information between the words in a line, and the page layout might tell you that by convention, if we can teach the software the conventions, it might say, oh, this stuff at the top of the next page, it's a figure. So when you're reading the text, skip it, just say, there's a figure here. Do you want to listen to it? And the ordinary paragraph that got broken from the previous page continues under the figure. So those sorts of things, and similarly, discretionary hyphens can be reinstated, because in the tech output, in the box, it records all the discretionary hyphens. If there's a discretionary appearing, it records it, and I believe it will be possible to reconstitute it. So that's the sort of how, and I'm going to do the Fermi estimate now. So Enrico Fermi was a great Italian physicist. He was both a theorist and an experimentalist. He was a good person to have as your supervisor. Several of his students got not just PhDs, but Nobel Prizes. And he played an instrumental role in the Manhattan Project, in particular, the creation of the first nuclear reactor with carbon rods as moderators. And he was supposed to be very good at estimating quantities with little information. So he estimated the power of the first atomic bomb, the one that was tested at Trinity, by the dropping of pieces of paper and how much they moved in the wind. So that sort of thing is called a Fermi estimate. So you use common sense and small amount of information to get a ballpark figure for something that you don't know, and you probably don't even know how to get an accurate figure for. So my Fermi estimate is how long will it take to reprocess the whole of the archive? And it might be wrong, but my estimate was that with 12 cores, so 24 threads, and if each item takes 20 seconds, then we can do the whole lot in about a month, running on one PC. And the electricity for it, because it's about half a kilowatt, will be about £150 or $150. So even though there's an enormous 2.25 million articles to process, if we can process each article in 20 seconds, we can do the whole lot in a month, assuming the overheads are reasonable and we can get hold of the articles and so forth. So it doesn't seem impossible, even though there's 1 million articles, and I hope that Fermi estimate is close enough. But 20 seconds isn't that long. So that's worth thinking about. But doing this estimate has given me a confidence that it might be possible to actually work out this whole thing. And if the whole thing takes a month, then you'll do a subset, and you'll say, oh, well, this subset looks all right. So you'll process the whole archive with that subset, and then you find that there are more things you need to add. And you might say, oh, well, I've now changed the software. I have to reprocess the stuff that I've done before in case there's a change. So taking a month is like a full-scale regression test, that the new piece of software does the same outputs as the previous piece of software. And a month for a full-scale regression test is a long time. So if you have 30 units, CPUs working on it, it'll take a day, which sounds a bit more reasonable. So as long as we can keep the time per item down to about 20 seconds, the size of the archive is not a problem. That's the sort of conclusion I'm coming to. And so where we are now is that I've got a toy example of constructing the Python object. And if I follow that with a toy example for constructing something that can be read, then we're in business. Because I can convert some articles, perhaps even to order, and ask somebody who's cited or not cited to read these articles and say, well, is the textual version okay? Can you understand the textual version? And every time there's something that doesn't work properly, well, I've got more work to do. But at least I've got a piece of software that works and I'm fixing it rather than not having anything at all. And I don't think I've written more than about 400 or 500 lines of code altogether, perhaps a bit more. So coming in at about 10,000 lines of code seems reasonable. I think with 10,000 lines of code, you could produce something that's, well, I'm hoping that something that has all the information required, but doesn't process it exactly the way you want it to. But that somebody such as Jason or anybody else that's got a wish to can hack on the code and say, well, it's not working for my document for this reason. Or it doesn't work for my project for this reason. So I can fix it, either by changing my project or by changing the conversion code. So I'm feeling optimistic. I have to say that sometimes I get blocked and then I feel pessimistic. So it's not a uniform state of affairs. But we've got something that's close to sort of working. The article I've chosen is Leslie Lamport's Introduction to LaTeX. I chose that in part because it's a LaTeX document and because it's fairly short and fairly simple. At some point, I suppose I should start with I should have a go at the archive's accessibility report, which is available in TechSource, I believe. That would be interesting. So, what's the word? I don't say I've got anything. When you build a plane, the first thing you do is what's called taxiing tests, which is, well, the first thing you do is you sort of check the undercarriages work and the engines work and everything. But before you take it to a test flight, you just run the plane up and down the runway without letting it get any speed at all. This is called taxiing trials. So I'm out to sort of do some toy examples along the lines of taxiing trials. And I'm also interested in doing some non-toy examples to see if I can make the software, to see if they can break the software. I'm interested in breaking the software, I'm interested in showing that the software doesn't work. And I'm also interested in showing that the software does work. So it should work on simple examples, and I'll be pleased if on complicated examples it breaks, because that will tell me that I've made a mistake in the software that I otherwise wouldn't have known about. So I'm probably going to stop there. I don't think we're quite yet at the situation. I don't think we're quite yet as a situation of, here it is, go and have a play with it. But I hope to get into that situation fairly soon. I don't think it will be before the archive meeting on Monday, but I do think it will be certainly available next month. So, sorry for the monologue.
I had a comment. I find it interesting that the place that you've put this data extraction in the typesetting pipeline really is sort of like what happens in compilers just before you decide which CPU you want to generate code for. You don't care what the front end language is. That means that C-LaTeX and Lua LaTeX and LaTeX and AMS Tech and Plain Tech and so on all should work in this system. And that's really quite nice.
Oh, well, thank you. You should mention the MagicWorks LLVM. You might even know what they mean.
Oh, yes. Yeah. Low-level virtual machine. That's it. Originally stood for it. Perhaps it doesn't anymore.
Yeah. On that, Rust is quite interesting because Rust, I think, by going through an LLVM, can actually be compiled to JavaScript.
Mm-hmm.
And I saw a GUI toolkit that's written in Rust that will run in the web browser as native, so to speak, as native code, but it also run on very, very small devices.
It can also compile to WebAssembly, which is, I think it's like a bytecode that runs in the same module that handles JavaScript interpretation, but it's a low-level machine language type bytecode that's not obviously for any specific CPU. And I know you can compile Rust to that and run it in a browser that way too.
Yeah. So
there was a piece of news that I've been communicating with Jonathan the past few days. Last week, I learned there's work at MIT to develop a compiler for Python that tries to avoid the overhead of interpretation and going directly to native code. And one of the things in their project is to produce WebAssembly using LLVM as the back end. And this turned out not to be as simple as I'd hoped. I tried it on about 6 different systems before I finally got one where I could build it on. But nevertheless, it's encouraging. And what it would in particular mean is that at the point they reach being able to turn Python into WebAssembly, a huge amount of Python software could now be essentially running in browsers at close to native speeds. And that's very encouraging.
Yeah, the ability to run the browser becomes a platform in a very, very strong sense. Microsoft, in the 1990s, there are these antitrust case against Microsoft, and Judge Jackson was the person that ruled on it. And it was clear that Netscape as a platform was a threat to Microsoft's business because you could produce a web app, although they didn't use the word, rather than write for the Microsoft desktop. And the browsers become a major platform. Indeed, a very major platform. And it would, I think, help the tech community a great deal if a version of tech was made available that would run in the browser and work in the browser, because that would provide reproducibility and it would lower the barrier to entry. You wouldn't have to install anything. You just have to wait 10 seconds until the download arrived for all the tech stuff you need, and then off you go. But I'd like to try to get back to this accessibility thing. The big difference, the Tech for HT and Al Warp have a similar approach to myself, except they do it after the PDF or the DVI has been produced rather than before. And because of that, they lose a lot of information. They lose, in particular, they lose the sort of explicitness of the tree structure. And they, the interword spaces, except after punctuation, are the same, depend only on the font. The interword spaces only depend on the font. ideally. But when you're justifying, they'll stretch and shrink. Now, in the box, that information is kept, but in the DVI file, it's taken away. The DVI file has, so to speak, frozen everything, and you can't reconstitute it. So the box sort of contains more information, and it's also easier information to handle. In some sense, it's easier to handle that information, I think, than the DVI information. But, oh, and it also works if you're generating PDF output, whereas the DVI output is, so to speak, out of fashion. So I don't know what, I'm clinging on to that as something that might give me an advantage. That's all I'm saying, is that it might give me an advantage that will avoid some of the problems that Tech for HT and LWARP have. But the question I'm interested in is this: there's a sort of, vaguely speaking, negotiation going on between myself and other people in similar situations on the one hand, and the archive and other organizations on the other, which is I want support and they want a solution. So they want to have confidence that I've got a solution. I want to have confidence that I'll get support. It's a sort of negotiation, if you like, or a sort of a dance, perhaps. So if I said, here's this software, I don't know if it works, will you run it on the whole archive so I can get some more information? You'll say no. But on the other hand, if I say, here's this software, I think it works, could you run it on a few documents and tell me what you think? You might say yes. So I'm trying to, what's the word? Start developing a community of interest. And because my approach is in some ways very similar to the LaTeX 3 project approach, because it's going via the PDF, I'd hope that they join in on this as well. So if nothing else, I can analyze the boxes that generate the PDF that they're outputting and check them for errors. Say, look, there's something funny going on in it, or this looks right, or how did you do that? I wish I could do that as well. So there's interesting possibilities here. But the thing that I'm most focused on at the moment is getting toy examples into such a form that somebody who's blind or visually disabled has a fighting chance of either directly reading the article through the information available or digging deeper into the information. To produce a rough rendering that somebody who cares about matters can say, well, this rough rendering is wrong, and I think I might be able to fix it. I'd really like to get to the stage where on simple documents, users could fix problems. That would be a really, really powerful point to get to. And I don't see myself doing that in 6 months, but I think that's has to be on the agenda. That here's a range of documents, and the output is close enough, and fixing the problems is easy enough that somebody can go in and fix the problems either on a per document basis or on a programmatic basis. I'll stop and try and give Kaveh or somebody else a chance to talk.
Thank you. I was just going to say something. So just, Jonathan, just to coming back to what you are doing here, you are, am I right that you are, in simple terms, you are running a file through whatever class file, style file, etc. And then at some point you're intercepting what comes out before it goes before it goes into a page, basically. Is that correct?
Yeah. From another point of view, I'm exporting the box that LaTeX and Tech together have generated into Python, so it becomes a Python object.
Okay.
And then it becomes a Python programming problem that requires domain knowledge to produce an audio representation of that object, of that document. In terms of LuaTeX puts Lua inside the middle of Tech, and it has a sort of pretty free reign to do whatever it wants to do. What I'm doing is I'm having two separate domains, and I'm saying we only look at the box that goes out. We don't look at the macros that generated the box. So there's a restriction on what you can look at. And the question is really, is it a useful restriction? It certainly has benefits because it's controlled vocabulary. You don't have thousands of commands. You've just got about 100 commands, perhaps not even that, together with parameters, which are numbers or letters, and a list of fonts. So it's a much more focused collection of information than all the macros and everything.
So
Christopher
when you say
wrote,
the macros of, I mean, your document has used the macros anyway. It's run the macros to spew out the letters and the H boxes, V boxes. So the macros are gone. Which macros are we talking about?
yeah, that's the point. The macros have gone. Let me answer a question from Christopher, which in the chat, which is he says, is there any information in the box representation that might allow somebody to know that the box represents some semantic element, like the title or the abstract? Well, how does a human being know that it's the title? The human being somehow can figure out it's a title. And it's the large font. It's the font that tells you it's a title. And how did they figure out it's the abstract? Well, there's the word abstract at the beginning. On a more secure basis, the macro that creates the abstract can put additional information into the box. And that's what's called specials. So you can just say, here's a bit of additional information. This is an abstract. And there's a trick that I spoke about the other day, which is you can use two identical copies of a font. For generated text, use one version of the font, and for ordinary text, use the other. And then you can immediately say, oh, this is generated text, or this is text that exists for some other reason. So the answer is yes, even without changing the macros, you can determine the semantics of the thing in the same way as the human being determines it. And the nature of floats means that they have certain penalties and glue around them and so forth. And that floats are usually contained in a box. So the box structure for a float is quite different from the box structure for the text that's surrounding the float. And the question isn't an abstract question. It is, for all the documents on the archive that we care to look at, maybe a 1% sample, did we get everything right? That's the sort of, and if we don't get it right, what do we need to do to get it right? it would be nice to have some sort of automatic fuzzing test that tells us whether or not we've got things right. So if we change the page dimensions, we'd expect the floats to behave in a sort of funny, different sort of way. We ought to get some consistency of the output, even when we fuzz the page dimensions. So the audio version of the book, here's a test that the audio is correct, which is that we fuzz the page dimensions, so all the page breaks and everything, and line breaks change, but the audio representation should be exactly the same. The audio representation should not change when we fiddle around with the document in that way. So there's an awful lot that can be done. And given the constraints I'm on of doing it in a year, we might go over time, but that's a sort of, I have no reason to believe it should take more than a year, except that I've never done anything this big in that sort of time period. But given that sort of constraint, one needs to automate everything as much as one can. So what one wants to do is have a process that produces noise with a very high signal in it. So it says, you must look at this and you must look at this. That's the quality control. That's determining things that have gone wrong. Quality control can't be checking everything's correct. It has to be finding things that are wrong. I'm waffling there a bit.
I had a question for Kava. I noticed recently at some publisher websites that when I visit the DOI for an article, it puts up a default view in HTML rather than PDF. And I just tested this with a bibliography updated a couple of days ago for the Journal of Econometrics. Just took the very last article in the most recent issue. And indeed, I get HTML. So the question is, this is a Science Direct Elsevier journal. Are they doing some post-processing on the XML, or are the document producers at the back end, like your own company, producing HTML for them?
Firstly, Elsevier is generally very good. The specs are very high, and they've always been, early on. For example, they've specified, this idea of XML first, that they create XML, and then from that they produce PDF, HTML, etc. And this is their vendors. So in general, what happens is they would send a file to a supplier or a vendor offshore, and that supplier has to create XML. So the answer is that normally that HTML is created directly from the XML, which is not too difficult if you've got good XML. And the PDF should also be automatically generated from XML. That's much more difficult, but ideally that should also be the case. So basically you've got what I call the format of record, as opposed to version of record, should be the XML. So basically, if you go back in 10, 20 years' time and say, look, I've noticed there's one certain name here in the XML, and it's different in the PDF, the publisher should be able to say, yeah, the XML is correct. That's something went wrong when converting to the PDF. So that's the normal way things are done.
Thank you for that clarification.
And so what that means is that the expensive part, given whatever the publisher receives in the original manuscript, is the initial conversion from whatever the input format might be, and they could be lucky and unlucky on that, into a properly tagged XML format according to their XML schema or whatever it is they're working to. And that's the costly part, unfortunately. I'm sure there are ways of making that less expensive by trying to get the original source format better than it normally would be. But I think that's where the challenge lies for the publishers.
Yes, thank you. So that's it. The challenge is going from a Word file or a text file, which could be anything. In rare cases, you might have just a PDF file. If I've lost my Word file, well, here's the PDF. So they send that out, normally a Word file or a text file. They send it out. And as you say, you might be lucky in some, unlucky in others. It's the job of that vendor, who the big vendors have literally thousands of staff sitting with computers and cleaning these up. But over the years, the price has gone down. I won't say what price, but you'll be absolutely amazed how low the price has got because of, firstly, offshoring, a lot of automation, and I don't know, just for whatever. And volume. So if a vendor has a huge amount of volume, for a big publisher, you can get lower prices. But yes, you're right. So the first thing is to create XML. Then from that, you create anything. Having said that, most vendors, they don't have that, what I call pure XML first. HTML is easy once you've got the XML, but the PDF, people often use InDesign, or there's a software called 3B2, or there's various professional PDF pagination software, and it's not a pure XML first. You might, for example, change the size of a figure. Typically, they'll change it in InDesign. They press the button, and then that spews out another XML. So that spoils the toothpaste out of a tube. But yeah, I don't have a lot of inside knowledge. As far as we're concerned, we are small vendors, but we're more technology now. We have no other way. We do not have a pagination, interactive pagination system. We don't have InDesign. So if we need to change a typo or a figure size, or a figure placement, we have to go into the XML, edit that, press the button, and the PDF comes in.
Which is better in the sense that the XML file then is the definitive form, as you said before, of the document. So in a sense, that's a good thing.
Absolutely. Well, I mean, that's my view. That's why we literally 25 years ago, we decided this. We said we do not want to use an interactive PDF. We'll build it. There's a lot of tech in there. There's a lot of homemade stuff in there. But yes, we've stuck to the pure system, and we can sleep easy. If the publisher says, "Oh, I've lost the PDF," we say, "Fine, we'll press the button and it will come out again." Or here you are, you can go online, press the button, you get the PDF. Or if there's a typo, you go through an interface, you edit through a sort of HTML interface, the XML changes. You press the button and all your deliverables come out. And the important thing here is, of course, it's good for accessibility. What we need is a clean, structured form, definitive form, which we use XML for, because from that, then you can render audio or braille or dyslexic typeface for dyslexic people, for example. But that becomes, once you've done the hard part, it becomes easier for accessibility.
That's exactly right. And yeah, all you need is XSLT.
Yeah.
Or and for instance, the DAISY consortium has software that you can download that they call the DAISY pipeline, that's written by people with significant XML expertise, and it basically runs a series of XSLT transformations that will generate different output formats for accessibility purposes, including Braille, including spoken audio, as well as various digital publishing formats. And that's a good example of what can be done.
Yeah, absolutely. So the DAISY consortium and other people, basically we see our job as creating the format of record as XML. Going from one XML to another is not difficult, as you say, with XSLT. Once you've got one, one structured form, then other people can take that and render it in any way. And, if something comes up in 20 years' time, you still have that original that you can render in other ways.
I'm going to relate that to my approach and the LaTeX ML approach, the R5 approach. So the box that's shipped out is the closest we've got to being a well-defined, specified object. So in that respect, it's like XML for a document. On the other hand, it doesn't have the structure, and the LaTeX source also has a claim for being the XML of the document. The difficulty we have is that neither of those has the same power as the XML. And pay me now or pay me later. You choose the one and you get advantages, but you also get the disadvantages. In my mind, I'm toying with the idea that certain parts of the document might be done one way and certain parts of the document might be done a different way. But that's idle speculation, as the lawyers say. What's really important is actual documents and actual readers and actual problems reading. And so that's why it's so important, particularly in this sort of rapid change, open source sort of approach, to get to market early. So that the first manned flight, the people that, not manned flight, human powered flight, the people that cracked human powered flight, they did not design a perfect aeroplane that flew. They designed an aeroplane, a human powered aeroplane, that could be rapidly reassembled and repaired and remanufactured as they learned from experience. I think that's quite interesting. So I want to treat this project in a bit in a similar sort of way. It's not going to be an enormous. I want it to be something that can be tinkered with. Now, the second thing is the role of the publisher in all of this. The publisher, printing. The invention of printing created the role of the publisher, just as the invention of the automobile invented the assembly line for the manufacture of automobiles. I seem to recall reading sometime, around the time of Gutenberg, there was a hand-copied, they have a scriptorium in the monastery, there was a hand-copied edition of the Bible in Paris that had about 20 copies. So that's what it was like in that age of hand copying. But with movable type, you could have an edition of 400 copies. It might sound like a small number, but it's 20 times 20. So that's the role of the publisher that is very closely involved, related to print or paper as the medium. If we zoom forward for 500 years, the model of publishing that the archive provides and the model of publishing that companies such as Elsevier provide are very different, in that the archive is, well, it's low cost and low profit also. Whereas Elsevier is based upon descriptions and control of knowledge and all sorts of other things. There's a lot of things we can talk about there. But what it means is that it's going to be hard to get $1 or $5 to fix the problems for each of the 2 million articles on the archive. it'll be hard to get that sort of money. Whereas I think a journal publisher can expect to spend $5 on each article without having too much of a bite out of their profits. Now, the difficulty we've got is that we don't have XML, both in practice and psychologically. We don't have a culture of XML, whereas the big publishers now do have very much a culture of XML. And that allows them to do much better with the accessibility. So looking forward, the whole thing is quite different. Looking back, the backlog on the archive there's not $10 million available to sort out the archive backlog. There might be $1 million available to sort out the archive backlog. I doubt it. I mean, that's something that could cause for a Fermi estimate, doesn't it? How much money is available? How much money would it cost to sort out the archive backlog? We don't have the materials, I think, at this time for Fermi estimate. All I've done is I've said, well, if we can do it completely automatically and we can do it in 20 seconds, then it's a £2,000 computer running for a month.
I think, we need to, there may be good solutions. Tech has a lot of advantages. Tech, you can generally, if the class file is there, you can run tech, it'll automatically, it'll expand, it'll give you the same output. And the sort of approach you're talking about, where you capture halfway before, basically you grab a bit like, tech for HT. Of course, that tech for HT is different because it embeds in the DVI. But it may be that, there's some elegant solution where you can take any tech file, because it's still giving these strings of letters and horizontal boxes that you were saying. So, that's what we need. The nice thing is that we have there are a lot of documents. They're almost all tech, and tech is designed to continue running unless you lost the class file, for example, which will need manual work. But you never know. It's worth investigating.
So just a question briefly there. So what was suggested last time this was discussed, when Jonathan's approach was less developed in code than it is today, was that the development towards tagged PDF output would necessarily involve capturing the structural information that would be used in the tagging. And I think your suggestion was that should flow through to the box before it goes to the PDF. And so I suppose my question is, has anyone implemented that part of it yet? And if they have, what does that now look like in your box output if it has the tagging information preserved in it? That would seem to be a step that would give you the ability then to map that to XML or HTML elements, for instance, and then you could write out a markup file appropriately.
Jason's spot on there. Thank you. Yeah. There is another channel, which is sort of dictionaries, but if we put that to one side, and the dictionaries can be captured through other means, but if the LaTeX people produce a solution, then I can piggyback on it and say, well, thank you for the information. I'll just use it straight away without bothering with the PDF. So there's commonality there. I think for some documents, there's a great advantage in having a tagged PDF, because it means that there's only one document to distribute. And it's like a sort of compendium document that has both versions in it. But I think there's a really big unknown, which is well, they're related. This is related to this is the negotiation I'm talking about. The first is, what quality can we achieve on the backlog, on the legacy stuff? On the legacy stuff, what quality can we achieve? And then the other thing is, what funding is there available? Now, these are clearly linked. You know, it's like going into a shop and saying, I'd like some apples. How many apples would you like, sir? Well, it depends how much they cost. But that sort of umming and ahhing about, well, I'll pluck a figure out of the air, $100,000. $100,000 is well under $1 million. If we can do the legacy backlog for $100,000, would somebody pay for it? The answer is we don't know. And we don't know what level of quality we could achieve for $100,000. We've no idea what level of quality we could achieve for $100,000 because we just don't know how difficult it is. The one piece of work we do have along those lines is LaTeX ML. And at present stage, the quality we've got is, 80% of the ARC documents complete, run to completion. So 20%, we get nothing. For 20% of the documents, we don't get anything at all. It might be worth spending $100,000 to get 80% of them converted, but we don't know. Having metrics, having reliable metrics that can be automated for quality would be really helpful. It's like the scaling is the problem. You know, an individual will be willing to spend perhaps 5 or 10 hours sorting out accessibility problems on their own particular paper. But that's several $100s.
But I think it's sorry, yeah, I think, you know, I'm optimistic that we can find a good solution. Firstly, on the LaTeX ML and R5, it's, you know, that's been astonishing what Dejan has done with, you know, 60% of 2 million documents. It looks good. What I don't know is how accessible it is. You know, I'm sighted, so I can read it, and it's you know, it's amazing. It's not clear about the accessibility. And I'd love to find out about that. I mean, if it's accessible, then to be honest, the job is done. You know, more or less.
They get the $100,000.
Whatever, yeah, they're done. I mean, there's no point, you know, great. But I had a look at the HTML, and the HTML. I'm not an HTML expert. And I'm not an accessibility expert. You know, obviously, I don't know how a screen reader would read it, but it's quite verbose. There's a lot packed into the HTML. There's several different versions, right? If you look at an equation, it's not, you know, it's nothing like you know, MathML. It's MathML, but there's this, that. There's lots of things in there. I have no idea, but so I'd love to find out, you know, how accessible that is. And I know that Archive are doing a kind of study.
I guess what might be nice answer for you, Kaveh, to that question would be, can we, from the LaTeX ML outputs, or through a modification of the back end of LaTeX ML, produce XML that has a particular quality? Because then,
yeah, sorry, go on,
the scripts that Jason is talking about will do the rest for you.
So from memory, LaTeX ML produces an XML file as its intermediate output step. So the answer would be that you're actually getting that as part of that conversion process.
Oh, that's really very, very helpful, because it's helpful to me because that will give me a check on my work, won't it? If
Yeah.
Somebody told me that Elsevier, when they were doing all the backlog of their journals going back to the 19th century and earlier, didn't use OCR. It's not reliable enough. They used double keying. You had a first keyer and a second keyer. And if the second keyer came up with a result, hit a keystroke that was not the same as the first keyer's keystroke, then they would be informed of this, and their responsibility was to choose the right value. Now, if the speech rendering of the XML from the LaTeX ML R5 is different from my speech rendering, then we have to resolve that difference. And if it's always in favor of LaTeX ML, we say, well done.
So what they do, if I'm remembering correctly, it's a while since I've tried it, but from memory, it's essentially a very complex Perl script that implements the macro expansion capability of a TeX interpreter. And it uses that to generate an XML file. And then there's a second stage that is run to turn that into HTML. And I'm sure there are various options you can set to control the output. So in response to the question of how accessible the HTML is, I think that would depend at least in part on the options you set.
Yeah, sorry, again, we've got to look at it. My feeling is that the best program to read TeX files is TeX, you know, because you don't have to do all that work. Again, I'm not an expert on LaTeX ML, but you're sort of trying to do what TeX did in the first place. If we can get TeX to run, then you know, as it's, I forget what the, you know, where the mouth or the stomach or the gullet of TeX is, intercept at the right time. It just seems to be an elegant solution to use TeX itself to understand TeX. That's the you know, and the other thing is, if I may say, Jason, there's XML and XML. I have no idea. It might be fantastic XML, it may not be. But you know, XML will parse and validate. I mean, all you got to do. I in my spare time, I go to publisher sites and I just download XML. A lot of them have it available, and I have a quick look. And within, you know, a couple of minutes, I see either very bad usage or straightforward errors in the XML. So that's the other thing. What we need, in order that we don't go back in 20 years and have to go through this again, we need somehow to get really good structured XML somehow.
Right, and I haven't looked at the LaTeX ML XML output. So I would expect that the quality would depend on the input document to some extent.
Yeah.
They can infer from it, and it's probably against their own custom XML vocabulary. So yeah, it would be variable, I would imagine, but I'm not an expert because I haven't gone through and looked at that and done that kind of preparation.
Same here. So I'm totally, yeah, unaware of that.
I'm excited by this, that that the intermediate XML, I mean, in a certain sense, I'm interested in generating an intermediate XML. And if we compare my intermediate XML with the archive's intermediate XML, and they agree, then what we have is what is the same calculation done by two completely independent processes coming out with the same answer, which even if you don't understand the software, and don't trust the authors gives a large amount of confidence, unless there's some sort of shared misinformation. But you know, if Carve and Jason add up the same collection of numbers and they both come up with exactly the same number, then we think, oh, the arithmetic's probably correct. And that's why I mentioned the double keying. So we don't have to go into the theory of this and that and so forth. We just say, well, let's compare the differences. And we've got 2 million documents to compare. So,
by the way, sorry to interject. Yes, double keying is something that was done quite a lot when these huge backlogs, and some suppliers, because basically, sorry, but labor was cheap in the third world, was cheaper than now. They did triple keying. So 3 people type, and when there was an error, 2 of them were right. Automatically, the machine would take the 2 that were correct. So there's no one to check. There's no one to decide. There we go.
There's the voting for you.
Yeah.
Yeah. So that would be really interesting. Or it could be really interesting, because we've got close to 2 million processed by LaTeX ML. If I process even 1,000 my way and compare them to the LaTeX ML, the point is, we write the software and then the comparison takes 2 seconds or some period of time like that. And you know, this is quite amazing. Now, how much is it? It's on. I looked today. A low power Amazon Web Services instance is about 50 cents or something an hour. You can't hire anybody for 50 cents an hour, even in the third world, even in the impoverished parts of the world. It's if the checking can be done, if we can apply computers onto the question of quality, then we're doing really well. And if you have 2 independent ways of doing the same calculation, that immediately gives us the benefits of double keying. And I feel very pleased, because I hadn't realized that there might be a way of solving the problem of quality other than asking lots of experts, other than a lot of crowdsourcing or something else, within the constraints of, we want to convert 2 million documents and all we've got is a measly $100,000, which is $100,000 is 10 million pennies.
There's a possibility that the computer says, yeah, these match. There's a possibility they may both be bad. They may be, there might be some conversion where the XML is not good, but they match. So it's not, I don't know, just throw that one in.
I'm sure that if you knew the algorithms of both, you could submit an article to the archive. Just as a brute force approach broke the one of the SHA encryption algorithms.
So what you
had
also
2 PDFs. You had 2 PDFs with the same checksum, but they're different. Jason.
Sorry, I'm sorry. So what you could also do, and this is starting to get interesting, I was listening to a podcast last week on the image description capabilities of the GPT-4 machine learning model, where it exhibited some capacity to convert images into textual descriptions and to answer questions about the images. So if you could run, if you had a model that was reasonably accurate at generating descriptions, then you could run all of the figures from your 2 million documents through one of those, and you certainly there would be an error rate, but it could be good enough that it would still be useful.